Hello, in this video I would like to show you an example for the Arclength parametrization. Here's the example I would like to discuss. So let us consider the following position vector for the curve. So let's say t squared 4t squared minus 1, 3t squared plus 4, and 5t squared plus 2. And then let's say t is greater than or equal to 0. So the question is find the Arclength parameterization. So R1 of S of R of t for t greater than or equal to 0. Here is going to be the solution. First of all, I need the derivative magnitude of the r prime, but let's compute r prime first. If you differentiate, you get 8t, 6t, and 10t. So let's compute the magnitude of r prime. 8t squared plus 6t squared plus 10t squared. You see that 6t squared, 8t squared is already 100 squared. Another 100 squared is 200t squared. So this will be 10 square root 2t, absolute value of t, but t is positive, so it is going to be just t. Alright, so next I will look at S, arc length, from 0 to, because t changes from 0, to t, r prime of u, magnitude in here, du. That would be from 0 to t, r prime of u is 10 square root 2u du. So if I integrate this, I will end up with S exactly. So 10 square root 2u squared over 2. U changes from 0 to t. And then S becomes, if you plug it t, and then 5 and 2 cancel, it's like 5 square root 2 t squared. If you plug 0, it is 0. So what we have is equal to S equals 5 square root 2 t squared. And then t is positive. If I solve for t, actually, t becomes s over 5 square root 2 plus minus. So I will take the plus sign because t is positive. In this case, r1 of s would be r of s, r of t of s. So it's like the same thing, r of t, let's call this like t is in here, t of s, same thing, t of s. And that would be 4 times, if I go back to my original parameterization, 4t squared minus 1, 3t squared plus 4, 5t squared plus 2. So 4t squared minus 1, 4t squared, I need t squared, right? T squared becomes s over 5 root 2, 4t squared minus 1, and the next one is 3t squared plus 4, right? 3t squared, t squared is s over 5 square root 2 plus 4, and the last one is 5t squared minus 2 plus 2, 5t squared plus 2. 5 times s over 5 square root 2 plus 2. So let's simplify this. You can simplify much, but I'll rewrite it now. 3s 5 square root 2 plus 4, and then 5s, 5 and 5 cancels. So this will be my Arclength parameterization. Indeed, if you just differentiate it and compute the magnitude with respect of SS, of course, then it turns out to be 1. So you can verify that the magnitude of this d over ds of r1 of s is going to be 1. It is of speed 1.